I think we're just waiting for Aaron. Yeah.
Yeah, only one. Yeah. So 2 minutes. So the alternative is if we start, Nazim, if we start from June 1st, and then hopefully Aaron will join later. So how about that? Shall we start because already 2 minutes past 8?
I think, yeah, we can proceed with this plan if he join in the middle, so we can just let him cut in. So
Yeah. Yeah. Okay, then in that case, no need to ask everyone to wait. Okay, Nazim, I let you host it.
Hello, everyone. Good evening or good morning or like good night. I don't know, like wherever you are. So my name is Nasim Hajari. I'm the moderator of this panel for tonight. So I would like to thank the panelists for joining us tonight. And let me just introduce the panelists first. So our first panelist of the night is Nihar Raj. She's a product management professional with a deep interest in emerging technologies. She is VP at Citibank and manages products for the banking, capital markets, and advisory division. Previously, she has worked as delivery manager at Nanopay Corporation, which was the 2019 Blockchain Company of the Year. And prior to Nanopay, she worked for HSBC and Bank of America in product development and commercialization. Neha is an engineer and a business graduate, and she likes wearing multiple hats at work, which I think it is really cool. And in the last 10 years, she has worked as a software developer, business analyst, scrum master, client delivery manager, commercialization manager, and product manager. She lives in Toronto, Canada, and has recently picked up coloring as an activity to beat the pandemic blues. Well, that's really great to have some fun activities for the pandemic. So our next panelist of the night is Carlos Garcia. He is the Chief Payment Operation Officer at Nanopay Corporation. Carlos leads the strategy and execution of Nanopay's global network expansion, which is directly connecting to payment ecosystem and or via partnership. This ensures the alignment of company controls across all products and make sure that the functions are compliant with all required regulations and policies. He also manages the daily core functions as partner integration and production system, payment operation, customer success, and fraud AML teams. Prior to joining Nanopay, Carlos was a senior manager for Deloitte working on the payment modernization team. And before Deloitte, he spent 12 years at Western Union Company as Vice President of Technology Delivery and Operation for Americas and Europe, responsible for developing an omnichannel network, which was responsible for 80% of the business revenue. Carlos holds a Bachelor in Business Administration from the FGV Business School of Sao Paulo, Brazil, and several compliance, security, ethics, and technical training courses offered through Western Union and Deloitte University. Our next panelist of the night is Jun Yu, who obtained his MBA degree from Chung Kong Graduate School of Business and his BSc in Physics from University of Science and Technology of China. Currently, he is the investment director in Ant Group and managing director of AT&T Capital. From 2013 to 2017, he served as director of a strategic development department in Renren Incorporation and senior investment director in Fosun Group, led the investment in SoFi Snowball Finance, GoGo Van, and from 2018 to 2019, he served as investment director of OKEX and founding partner of OK Capital, led the investment in Anchor, Seller, and Certic. And last but not least, Our next panelist is Aaron Liu, is a University of Alberta alumni back in 2011. He was working in different IT industry companies such as IBM, BlackBerry, MC2, Intuit, and Electronic Arts. So reaching areas through fintech to cloud gaming to e-commerce as a tech lead. He mentored different levels of developers from co-op students to senior engineers. Now he's a lead engineer at BestBuy Marketplace R&D. So again, thank you everyone for joining us tonight. And I just wanted to remind our panelists that since this is like we don't have really lots of time and we have only 1 hour for our discussion. So if you can limit yourself, like the discussion within a 2 to 3 minutes time limit, that would be really perfect. So let us start with the question. Did Aaron join us? Should I start from?
Yeah, I'm here. Sorry
Okay.
guys for late. Yep.
Yeah, perfect. So, okay. So the first question is for Aaron. If you could please tell
Nasim?
Yeah.
Nasim?
Yes.
How about Suji can introduce Aaron first?
Sure. Yeah, sorry. Go ahead.
Hey guys, can you guys hear me?
Yeah.
Okay, I saw Tim was talking about this one. So yeah.
Sorry, I wasn't like unmuted. So I think Nassim already introduced Aaron once. So I just add some more information that Aaron was actually he is the alumni of the University of Alberta, and we actually enrolled the same course. I think that was a computer vision course back in like 2020. 2012. Sorry. And yeah, and he, as I think, as like Nassim introduced, he was working in different IT industry companies such as IBM, BlackBerry, and EMC Square, Intuit, and EA. And currently, he is as a like tech lead. He actually like mentored different level of like developers from prop student to senior engineers. And he is now a lead engineer at BestBuy Marketplace R&D. Yeah. So that's basically the profile.
Do you want to add any thing for June as well? You know him well, right?
Yeah, I think his profile and a short bio already like talk most of the his details. He's currently the investment director in the Ant Group and the manager director of AT&T Capital. So because we White Matrix work closely with Ant Group, so yeah, so that's the connection between us. Yeah, basically he's a experienced like an investment like a manager, and I think he will join this panel from the view of a like investment manager's view. Yeah.
Okay. I also see Francie already joined. Francie, do you want to say something?
Hello, everyone. Yeah, really nice to see everybody on the panel. I'm really looking forward to the discussion that is going to happen here. And you know, it's you know, Nazim and Shu already introduced all the panelists here. I don't have anything more to add to it, but I'm really looking forward to the panel discussion today. Thank you.
Okay, so I pass back to Nazim.
Okay. So thank you, Francie and Tim. So let us start with the questions. The first question is for Aaron. So Aaron, if you could please tell us a little about a product or project that you have been working on for data science and blockchain, and then like tell us how did you start your journey in this world of data science and blockchain?
Well, first of all, thanks for having me. It's my pleasure to join today's topic in that part. See a lot of old friends, teams, and Shell, everybody's in here, and thanks for having me. So first of all, these are great questions. So that's led me to memorize one of the products I work at the gaming industries. So which the system was handle like all the global sports title games. Like if you are a gamer, like FIFA, NBA, NHL stuff. So all the gaming data streams about this one. So basically, the platform needs to analyze all the player data, game data, and the video data in different perspective as raw data. So for example, if I would like to aggregate, I use soccer as an example. If I would like aggregate Cristiano Ronaldo's shots in a particular angle on PlayStation 5 for European regions during Christmas times. So those model was built and generated from data analysis team and using the services as on a private cloud platform to facade the data streams and more valuable data to each team as model needed. So when I first start team, I genuinely know what they're doing, but not specific details and how each partner teams work together. Once I started, the amount of data streams in this and the time duration and the throughputs the system can handle in the way of the business as needed are quite give me the passion, quite let me to involve in the interesting, leading my passion to the data science world starting that I opened that door. So that's my perspective for this part.
Thank you very much. That was really an interesting point of view. So the next question is for June. What has been your experience in the blockchain and data science space? So what sparked your interest in this world of emerging technology?
Hi, everyone. Thanks for having me here. I walked into blockchain space since 2017 when I joined one of the largest crypto exchange, OKX. I started the OK's investment arm, OK Capital, and led the investment in a series of blockchain companies such as Anchor, Seller, and Certic. Before that, I was a VC investor for around 10 years. Blockchain really has the distinct benefits such as decentralization, transparency, distributed structure, and immutability. So that's why I focused on blockchain investment since then. And last year on, I helped Ant Group and Financial to start a blockchain fund, a co-GP fund, and is a major GP and LP because we believe blockchain can go far beyond cryptocurrency and Bitcoin. Importantly, it can accelerate financial inclusion for 1.7 billion unbanked people by providing a decentralized, no minimum cost, low barrier financial infrastructure. So this is my background. Thanks.
Thank you very much for sharing your journey with us. The next question is for Carlos. So Carlos, we would love to know if you have been associated with any blockchain related projects. Can you please share that with us?
Yeah, thank you. Thanks for having me here. And just a brief history, right? So I've been my life in payments, like 20 years of a payment. I've been on traditional financial institutions. And I saw that the future of the modernization, what we need, the problems that we have in payments today, the only solution that I could see that is feasible today was blockchain, right? So that made me actually go out from the traditional financial industry and join actually a blockchain company that is Nanopay, that it was the blockchain of the year in 2000, last year, right? Yeah, I think it was last year. And actually, because blockchain resolves all the problems of a payment, right? As you were saying, like it's almost real time, it's immutable, it's transparent, it's traceable. So and that's, I think, all my projects right now are being sitting on the blockchain. So it's pretty much everywhere. Like every single payment infrastructure we try to design uses this kind of infrastructure. So that's where I am here.
Great, thank you so much. So the next question is for Neha. How did you become interested in blockchain and data science?
Thank you, Naseem, and thank you, Francie and Irene, for having me here. Yeah, so my journey with data goes way back when I started my career 11 years back. And I have been involved with data some or the other way since then. So when I started as a software developer, and I used to write code for reporting and analytics tools. And but then at that time, I did not know the implications, or I did not know that I'm creating analytics tools. And so while doing all of that, I got extremely comfortable with dealing with data and creating large and complex SQL blocks or Java codes for reporting tools, and or even taking a look at enormous spreadsheets. I got so comfortable, but I never realized I was developing that skill. So I moved on to various other projects, and over time I realized that most of my professional recognitions or rewards were related to my work on data. And that's when it struck me that that I'm good with data. And then I started exploring data science related content. Now, coming to blockchain, I attended my first session on blockchain based coin in early 2016, and that was pretty much my first exposure to blockchain. And at that time, all I knew about blockchain was that it means Bitcoin. And then I got to work on creating so I was working with HSBC, where I got to create a commercialization plan for a large trade finance project, which was built on blockchain, which broadened my exposure with various use cases of blockchain. And if you haven't, so far figured out that I worked with Carlos. So yeah, so as Carlos mentioned, I worked with Nanopay, and Nanopay uses another form of ledger technology, which is centralized ledger technology, where we had built payments and treasury treasury product, which was built on the centralized ledger technology. And so there I learned about the other types of, other flavors of blockchain, you can say. Yeah, and that's my journey.
Thank you so much for sharing that with us. Going back to Irene, since you graduated in 2011 from University of Alberta, how has the tech industry evolved with respect to blockchain and data science?
Gotcha. So that's a great question. So basically, until today, I still remember several of my university courses. Like for sure, we need some basic like operating system, algorithm, network, and database. Those are quite basic stuff, but very important, at least to me, for my career, goes longer and longer. No matter it's blockchain or distributed systems, or how I understand the data analysis in data science, or even the mathematics behind these ones. So, for example, data science, like I still remember, I'm not sure today's the database courses high level talking about the OLTP and OLAP stuff in these cases. Today's industry, like with a different data pipeline, even the streaming data in different cases are still useful by the theorem I learned from university time in that part. And for sure now industry turned toward into something called the data lake, which is another levels of how to handle a pool of raw data with a new like that before, the data warehouse as a repository of the structure in this case. So if I go back to university again in that part, I'm definitely going to compare today's courses with the latest industry's technology as well, to see how I can get my career path grow in the long term and grow in an efficient way, I would say.
Yeah, interesting. Thank you so much. Let's go back to June. And how is the adoption of blockchain evolving in the Asian market? So what is your opinion about that?
Yeah, we see a growing adoption of blockchain application in Asia. Recently, our fund, ANT Capital, invested in a project named Now's Finance, a DeFi lending protocol for real-world assets. The real-world problem it addressed is the small and the medium-sized companies and the merchants fail to get business loans from banks, as they have shorter operating histories, and insufficient collateral. Now enable the origination and the funding loans without traditional intermediary by an on-chain, off-chain structure. The asset based on Now's finance differentiated protocol and will allow it to create more interesting DeFi applications, such as this kind of projects emerging rapidly in the Asian market. So I think this is a major example of the adoption of the blockchain in the real world in Asia market.
Great, thank you. Carlos, coming to the North American market, how do you view the adoption and growth of the blockchain in recent years?
Well, it's hard to answer in 2 minutes, but trying to summarize, right? Again, blockchain resolves most of the problems of the payments, right? In North America, the adoption, it is not as fast as the emerging countries, right? So emerging countries, the cost is always one of the biggest area of focus they have. And using blockchain and allows them to do the micropayment. So I can actually do a electronic payment of 2 cents, 3 cents, and still have the cost to move that structure, right? That allows you inclusion. So in North America, they don't have that need. So it is moving, but not as fast in other regions like Asia Pacific, right?
Yeah, I think I agree with you. So Neha, we see that the adoption of emerging tech is primarily driven by startups and tech firms. How do you see the large enterprises such as banks and traditional organizations adopting blockchain and data science?
Okay, so while startups and big techs lead the space, they do deal with less complexity of implementation. And I've worked in both spaces. The issue with enterprises and large organizations is that they were built on legacy infrastructure. And so they not only have to adopt new platforms, they also have to figure out how to integrate with existing platforms. And that takes time. So having said that, most organizations have adopted technology pretty well. Predictive analytics has been around for a while, and there is huge investment in building innovation departments that focus on solving problems through emerging tech. I've read about city police departments using models that predict the probability of crime in different parts of the city, and I can certainly cite a few examples from the financial services. JP Morgan just announced the digital coin for payments. Last week, HSBC launched AI Max, which will analyze data, rebalance the asset allocations, and suggest to clients which assets to invest in. And very recently, I think April 1st week or so, Citi and IIDB had completed a cross-border payments pilot with blockchain, where IIDB dispersed tokenized funds from US to a recipient in the Dominican Republic using LagChain, which is a blockchain network. Yeah, so that I would say that traditional organizations do recognize the need to adopt emerging tech and have been doing fairly well.
Interesting. Thank you. Again, going back to Irene, what will be the future of e-commerce with the use of blockchain and data science?
Okay, the future part of this ones. Okay, if I speak e-commerce, I try to see 3 things about the future part. One is today, sometimes it's a little bit anti-business model in that part. Business will still need time to let the market to approve these ones. But I really want to see a true peer-to-peer network on e-commerce with, especially in marketplaces area in that part, without like one company hold the business models. I know sometimes technology cannot solve all the solution, especially in industry in that part. But that's one of my wish in these cases. And if I have to say from data science perspective, I want to see the circular economy in e-commerce to see how today, especially the product across different nations and across different countries doing e-commerce, either on marketplace or the traditional e-commerce in that case. And for sure, today I know a lot of like e-commerce gigantics, they are doing like data analysis on video part. So video e-commerce is, especially video e-commerce in social media, is already happening in, I would say, in e-commerce today's, like, for example, like Alibaba or TikTok, they are already doing those things. TikTok, like, for example, is, or Facebook, they are pushing a lot of stuff on their marketplace to selling stuff from video. And video data analysis is a trending things in e-commerce and marketplace. So that's the three things I really wish industry can adopt it and to see the next iteration on top of it.
Oh, Nassim?
Nassim, you have to unmute.
Sorry. Okay, so thank you so much. Okay, let me, oh, sorry, I kind of, okay, there it is. So I'm going to go back to Carlos, and sorry, the order is just kind of like messed up a little bit. So Carlos, how do you see the world of payment being impacted with the use of blockchain?
Well, again, I'm going back to say that everything regarding a blockchain actually sounds like the solution for the problems that we have payments today, right? So there's a lot of events that we need to do in payments, not only the payment itself, but everything surrounding the payment, that actually the clearing and settlement, all the KYC, everything that we need to do actually to execute a payment. Not even talking about the cross-border payment that actually brings other components that makes even harder. If you try to send a payment cross-border, you see that it's very expensive and takes long, right? So all these problems that we have today with payments, make it faster, almost real time. Make sure that, for example, KYC, it's mine, it's not the bank's KYC, so everybody can see my KYC actually reading with my consent, the blockchain, right? So all my history, the history is mine, the identity is mine. So all these problems all the solution for the problems that we're seeing today, the only technology that allows us to do on a foreseen future is blockchain. So I do believe that, I'm not saying that far, and COVID is expediting this, right? COVID is making the need of the digital payment more and more a need. The situation that we had where the government needs to pay people now, they cannot wait for a check, they cannot wait for a bank transfer. They want the money now, and it's not a lot, right? So it's micropayment. So all of this came like right away with this COVID scenario. So I'm foreseeing 5 years, everything that we see in terms of payments is going to be very different from what we have today.
Okay, thank you. So going back to Neha. So we heard about the use cases of blockchain so far. How do you think data science is being used in tandem with blockchain in the industry?
Okay, to answer that question, let's first talk about the biggest hurdles for data scientists. They have to deal with bad data and quality issues such as duplication, missing data values, errors, and junk. Adding on to that, we also see issues with data access, privacy, and authenticity. This really restricts the development of data science. Now, blockchain has real potential because it brings a high level of reliability, trustworthiness, and veracity to data. The immutable nature of blockchain certifies the data consistency because once the data has been recorded on blockchain, it cannot be edited or deleted. And data is on real transactions, therefore authentic and real time, which further empowers data science to develop models based on real-time data. So blockchain adoption has grown rapidly over the years, ranging from cryptocurrencies to food supply chain management. And as these applications proliferate, so does the complexity and volume of data stored by blockchains. Data science is all about analysis of data. When paired with blockchain, it will turn into something far more structured and concrete, and will become more powerful and more useful. So it could predict the price of Bitcoin, or devise fraud detection models on cryptocurrencies, or predict which supply chain distribution route has probability of shrinkage. Another example could be building models that predict probability of medical conditions in individuals whose personal health information is encrypted and shared on electronic health system, which is built on a blockchain. So blockchain helps data science by overcoming issues of privacy, authenticity, and asymmetric supply and demand of data.
Great, thank you so much. For the next question, I'm going to ask Aaron. So like you told us about the future and how do you see the future, but can you please tell us about a few implementations of blockchain and data science currently in the e-commerce tech industry?
Oh, sure. I will cut with data science first in that part. So high level speaking, data science serve a lot of places in e-commerce today. It's kind of easily transforming the benefit and the e-commerce business immersely in that part. One quick example is, for example, product recommendations in the recommendation systems, how the data science model going to build, or how intelligent machine learning can build those models rather than we re-implement again with all the data scientist teams and the data analysis team together as a quick examples. For sure, there are user experience analysis in these cases. I believe not only in e-commerce, there's others area definitely using data science as a topic, as a tool to get their beneficial words in that part. And really want to see, again, as I echo to the future one, several of the marketplaces already have the video data analysis as assortment levels in these cases. So that's one I really would like to see in a lot of marketplaces, not only in the gigantic company marketplaces, but also in small marketplaces not a huge like Amazon's. I know Walmart, Superstore, they all going to, well, they are already have their marketplace, or they are all going to do their marketplaces in this case. So I really want to see in next 3 years, 3 to 5 years, there's a new business or new startups that really have those marketplaces, mature marketplaces compared to gigantic in that part.
Great, thank you.
Yeah.
June, going back to you, what are the size of investment being made in the data science startups and techs? And do you see a significant change in the trend of the size of these investments?
Well, for our fund, A&T Capital normally invests in ticket size of around from 500K to $5 million. We do see that the industry continue to consolidate and mature with funds going to later stage fundraising rounds. We saw a lot of big fundraising activities recently, such as Dataku, one of the biggest global business AI and machine learning platform, announced in last August 100 million Series D investment round headed by Stripes, and Csense, a leading analytic platform, announced a fundraising of over $100 million last year. Data has become the most critical asset for companies in the age of AI. Data science platforms finding much traction among investors. Yeah.
Great. So following up on that, given that now everything is shifting into technology now, June, do you think that functions like fundraising, investments, M&A could also be career options for the students that are graduating in STEM, courses and careers? Yeah.
Yeah, I think investment is definitely an option for STEM graduates. For example, myself is a STEM graduate. I major in physics in my college for the college bachelor degree, and electrical engineering for master degree. So and more than half of my colleague either in the investment team of and group or my fund team, more than half of them are STEM graduates. I think it's very important you have a STEM background for the reason investment, especially more and more important in the most part of the investment now by the thesis of technology driven. So I think when it comes to the primary investment, there are a lot of technology focus on focus funds. STEM graduate can have the background knowledge for the specific industry and innovative technology. Those advantages can make the career in the financial industry. It's a very good option for the STEM graduates.
Yeah. Great, thank you. So Carlos, like we talked a lot about the technologies and AIs and data science blockchain. So what do you think is going to be the future of the digital currencies?
Sure, just tying what Yoon just said. For example, I see the future of fundraising is going to be an ICO, right? So the company opens an ICO, opens a currency, and can get funding instantly, micro investors, big investors, wherever. But it's going to be way different from what we have today. So CDBC, central bank digital currency, it looks like it's distant, but we have more than 60 central banks already evaluating that since 2014, right? So you can divide that in retail applications and intra-bank. It's very expensive. Like we estimate the banks spend about $10 billion in moving money around just to support the infrastructure, right? It's just a waste of money moving around because of the current infrastructure we have on the finance industry. So CDBC is going to be a reality. And again, COVID is pushing for this, right? In order to push payments fast, I cannot have bills, I cannot have currency, I need to have something fast, right? Acceptance of this electronic needs to actually grow. And this is coming with the phones, right? So everybody's getting a phone, so it's going to be easy to actually have something digital to replace my wallet. I don't need my wallet anymore, just need my phone. So it's going to be something, countries are hesitant. They're just waiting the first one, right? The first big one. We have some small ones that are already going digital, but I think everybody's studying there. They know they need to go there, but they don't want to be the first. That's, I think, the big challenge, right? And also there will be a transition period where you need to have the old talking with the new. And that's the challenge when you have both technologies working at the same time, and you need to live with that, right?
Yeah, it's very interesting, definitely. So for the last question, Neha, how would one become a product manager of a blockchain or data science product? So what do you recommend?
So product management lies at the intersection of business, tech, and user experience. Anybody who can empathize with the end users, thinks in terms of business value-driven features, is tech savvy, is a good candidate to pursue product management. In terms of technical skills, of course, if you have to manage a data science or a blockchain product, you should know about it. And you should know what problems can be solved using blockchain and data science, and what is the life cycle, how it can be implemented. Now, apart from that, you also have to learn the fundamentals of product management, which range from customer interviews, mapping user journeys, defining problem statement, to prototyping, researching the market, managing metrics, a lot of things, aligning to business goals, how to launch the product, and much more. But the good thing is that there are so many free resources available that anybody can pick up the fundamentals. And one important thing to add here is that the JD of a product manager differs in every company and even types of industries as well. So you'll have to research what types of products and roles interest you more. Additionally, the knowledge of the role of a product manager in an agile environment, in an agile sprint, is also important. And well, I can talk a lot about this, but I would say if anybody's interested, feel free to reach out. Thank you.
Great, thank you. So now I would like to ask each panelist to give their closing comments on this discussion that we had today. So Aaron, if you can let us know about if you have any other comments or any other ideas, basically perspective, then we would be happy if you can share that with us.
Sure. I want to echo, first of all, this is a great opportunity to speak out and to meet everybody, to know a lot of new areas with different scope and different perspectives, see that part. I would say technology is always changing. The only non-change part is the changing part. So today we talk about blockchain technology in that part. We talk about data science in these cases. Further down, there will be other new name, the buzzword comes in there. I believe as from a tech people perspective in that part, I would say how are you going to land with industries? How are you going to solve a real problem with industry and academic together in these cases? So I really looking forward to those two areas we talk about today in the futures. And I encourage everybody who loving or be passionate with technology, not only these two areas, going to have a good career for themselves. Yeah.
Great, thank you. Yeah, it's definitely true. So June, what is your basically perspective and your closing comments?
I think blockchain can ensure data analytic with privacy and protect the sensitive data. Privacy computing is also one of our major investment focus, as well as that can include a combination of blockchain technology and zero proof knowledge, multi-party computing, and so on. For example, using MPC, the privacy key, private key of the digital wallet is broken up into share, encrypted, and divided among multiple parties. So I think it's a very big market, a lot of opportunities to let us involve in. Yeah.
Thank you so much for talking about the privacy. That's definitely a very important topic. So Carlos, what is your perspective?
Yeah, I think it's pretty much independent of the technology, right? We're talking about blockchain because blockchain, it is what fits best on the trends that we have today. The trend is decentralization. It's taking ownership, right? So I'm taking ownership of my identity. I'm taking ownership of my information. Everything is decentralized. Today, I'm used to say that you are not a customer of a bank, for example, you're hostage. Because if you want to leave, it's painful, right? So everything is turning to be open. So open banking. So everything is trending to you taking ownership of what is yours, right? And the technology that fits this today is blockchain. Maybe tomorrow we have something new, right? But I think that's the trend, and that's why it's interesting that whatever application probably you are going to find a way to fit the blockchain, right? It's like Neha was talking about the medical. I think everything that you have in your war wallet, money, ID, your medical history, you can fit on a blockchain, right? This is just a few examples. So if you want to follow any of those three careers, like plenty of opportunities on this.
Great, thank you so much. And Neha, could you please share your opinion with us?
Yeah, thank you, Naseem. So all panelists have covered a lot of points here. I would say that this is a very good time for anybody who's graduating, from a technology course, because technology no longer is an enabler. Any industry is now being disrupted by technology and the use of technology. If somebody at this juncture of time thinks that they don't need technology, they will lag behind. So I think this is a very good time. And additionally, I don't think that one technology can be isolated. Everything works in tandem. So blockchain, AI, data science, analytics, cloud computing, IoT, everything works together. And so I think as technologists, while we have a very specialized view on a particular technology, it's very important for anybody in this space to also have a holistic view of how each technology, works with other technologies and what are the broader use cases, how it can benefit. So I think that's a very good point of view to have. And that's my comment. And thank you very much for having me here.
So thank you all very much for joining this panel tonight. It was very, it was a great, really discussion, and I'm pretty sure that everyone learned a lot from this panel. So now I would like to ask audiences if they have any questions. So like if the audience can basically unmute and start like talking, asking their questions from the panel in general or from any of the panelists like specifically. You can also send your questions in the comment section if you guys have any questions.
Hi, my name is Ishtiak. So I want to ask a question to Carlos. So Carlos, do you think that the decentralized nature of the blockchain makes it more secure? And if yes, why is that?
Well, it's more secure because always we try to decentralize, for example, the databases, right? And have different sites. And we always decentralize when you have a financial infrastructure. Blockchain is by nature like that, right? And you have everything done by concept. So it is more secure, I think, than traditional databases, let's say this way, right? And you have a lot of other components that can help that to actually being more reliable than traditional databases. So again, it's the only technology that we can see right now that actually can fit the needs that we have. Maybe in the future we're going to have something even better, right? But as is today, I believe blockchain is the way. And again, it's not only that, like Neha was saying, right? When I talk blockchain, it's for the payment specific, but still have AI for fraud, right? You need to put everything on each slot. But today I'm just focusing on a blockchain, but actually you can fit all the components of AI and everything that we need in terms of technology on the satellite systems that actually help to move money around.
So is it possible, right, to hack the blockchain? And as there were like many reports of Bitcoins being stolen and so on. So what do you think about the hacking of the blockchain?
Well, my experience, everything is hackable. Like it's a question of time, right? So you always need to evolve. You can never stop. You cannot assume you're 100% protected. 100% doesn't exist, right? You always need to be protected every single way you can and have a plan B, right? And always be like on the edge in terms of technology. But it's a reality. Like we know attacks are imminent, but that's why the decentralization also helps, right? If you're being attacked, everything is not sitting on the same place. If it's decentralized, it's harder to the hacker to actually find what they need, right? But again, I don't have a response for that. I believe nobody has, right? Of being 100% foolproof.
I can support a few points that Carlos made. So blockchain is secure because if one copy of the data is corrupt, you have millions and billions of other copies. So it's very hard to corrupt the data. It will be authentic. And that's why it's very difficult to hack. Plus, in this distributed system, you have to have consent of at least 51% of the nodes. So the larger the network, the more difficult it will be to hack, to break the system. But yes, of course, any system is hackable.
Exactly.
Yeah, so yeah, coming to Neha, I have one question for you. So we have learned a lot of advantages of using blockchain. So what do you think are the main disadvantages of using it?
Okay, the biggest one is the cost, because it's very expensive to implement so many nodes. As I said, the larger the system of nodes, the more secure it is, but it is highly expensive. Plus, a lot of blockchain is stored on file systems, not so that also make it. File disks. So that also makes it quite expensive. So infrastructure is the biggest challenge with blockchain. And maybe I'll leave Carlos to if he wants to talk about the centralized version of how
I think
we.
I agree, Neha, and time, right? So today, to get the consent that Neha just said, the transaction takes time. So it's one of the big challenges on the blockchain today is speed, right? So you need to have a consent of 51% instantly, and we don't have that today, right? Today, if you have a Bitcoin, or it takes time until you have the consent, right? I think it's one of the biggest challenges, at least for me in payments.
Right.
Great, thank you. So any other question? We can take one more question from the audiences if there is any other question.
Hi, I have a question to Neha. So as you were working as a senior product manager at Citibank Toronto, so my question is for a recent grad student. So what would be the what skills should focus here to work as a product manager role? Because of I think many recent grad has not that much of working experience. So yeah, so if you can give us some insights from that, like which place we should more focus to build a portfolio. So if anyone want to work as a product manager role.
Okay, so while I've covered this answer in my last question, but I would quickly summarize. So as somebody who is starting, I think you should know what's the role of a product manager in an agile sprint, because you're starting, right? So a lot of that role would be writing user stories and epics. So you have to understand how a product owner works in an agile environment. That's the key. And you should know how to use these UX tools. So for example, if you know how to use Envision, etc. So generally, typically, these are starting level. Associate PM or junior PM works a lot on these kind of processes. So that's where you start. And there are a lot of free resources to refer to.
Thank you so much.
And never keep the customer out of sight. You always need to know your customer.
Yeah,
Great.
definitely.
Thank you, Neha and Carlos. Now, I would like to ask June and Aaron about their ideas on this, questions that people just asked. So, what do you think about the background that the students should have, like if the new graduates, if they want to join this industry? So what do you think are the disadvantages maybe of the blockchain? So like Neha talked about the cost. So do you guys have any other comments on that?
Cool. I really want to chime in one thing. Totally agree, Carlos and Neha's points with that part. So I was a student from U of A. I took a large advantage from the second year when I started building my career portfolio started earlier that time. And I'm directly targeting the internships. I think at that time, still calling the IIP, the internship in the industry internship program. I was doing that path in these cases. My goal was strictly after graduate, I'm going to work in industry in that part. So I would recommend to build the career portfolio. If you want to go that path, build a career portfolio earlier and have as much internship as you can, because in industry, interns is a quite opportunity. You can taste or you can try a lot of opportunity in different company or different environment or even different industries in this case. I'll just add one more thing on top of that.
Great.
Go
ahead, Joe.
For my advice is that there are more and more opportunities for recent college students to participate in blockchain industry. It's a totally decentralized industry. You have a lot of opportunity, even you're based in every corner of this world under this reason and circumstances. You can jump in the a lot of projects, their Telegram group, Discord group. You can find out a lot of needs for their projects. If you are engineering students, you can contribute your code. If you have some marketing or product ideas, you can just contribute to the community. So there are quite a good incentive for even college students. If you participate in the project in the very early stage, you can get a quite good paid. So I think it's more and more much better than I was a college student for this time. Yeah.
Thank you so much, everyone. So it was really a great discussion. I know that people still have questions. So Stephen posted a question on the chat. So maybe like if you can, one of you can very quickly try to cover his question. So he asked, what are the motivations for current centralized organizations like giant companies or even national banks to change to decentralization?
It's a very good question. Well, if I can answer that, I can talk about the banks. None, right? Because this decentralization means we are open the market, right? So you're, for example, Canada, right? Canada, you have 5 banks, big banks, and they dominate the market, right? They don't want new entrants. They don't want cheaper services. They don't want, because that will compete with them, right? If they start decentralizing, open the market, it's going to have more competition. So that's the fintechs, right? If you see it, all the innovation is coming from the fintechs. It's rare to see a bank actually using blockchain, right? They do tests, they buy fintechs that they're using, but they don't adopt, right? Because there is a conflict of interest. So it's not going to be easy, right? Usually what I'm seeing based on my experience, some countries where actually the government mandates, for example, I'm originally from Brazil, right? In Brazil, they just implemented faster payments. In Canada, they're trying to implement faster payments for 5 years. I think the first time that I saw it was 2018 or 17, something like this. And they're still not moving, right? But in Brazil, the difference is the government said, banks, you need to do it, right? It's going to happen. So if you don't have this, actually the disruption, the openness of the market, it's not going to happen. So it's a political change too. It's not only an evolution of technology, let's say this way.
Thank you, Carlos. I'm sorry, I have to close this panel. It was very interesting discussion. I'm pretty sure that people still have lots of questions that they want to ask you guys. But again, thank you so much for your time for the night. Now I would like to invite White Metrics to give their closing seminar speech. So thank you again.
Thanks, Nassim, and all these panelists. This is a really good discussion. I think it's kind of broadened the vision and in light of the future ways of how we think about the blockchain and the data science and the multimedia. Here I'm on behalf of White Matrix to give a closing speech on this. So first of all, I would like to thank all the speakers and the participants for their excellent contributions to this BMDS web seminar. So this web seminar, actually, we reviewed the basic knowledge and the state-of-the-art research and applications in blockchain, multimedia, and data science. So in blockchain area, our topics range from basic knowledge, such as blockchain data structure, consensus, to the latest applications such as decentralized finance and non-fungible tokens. So in the multimedia area, we also learned academic knowledge such as image processing and motion capture, as well as applications like interactive multimedia games. So in the data science area, we learned the idea of machine learning, deep learning, as well as the latest application of these techniques in the industry and in the modern data processing pipeline. So I believe both newcomers to these areas and the practitioners already in these industries can benefit from these presentations and discussions. Also, we saw many presentations and discussions about cross-domain research, such as incorporating blockchain with computer visions, blockchain-based multimedia games, and applying data science technology to blockchains, and even more far future, the metaverse and the immersive digital world and digital arts. So these new directions proposed by the presenters give us numerous inspirations on where we should focus on in both research and engineering sides to build a brighter future. So lastly, I want to thank all the participants' contribution and the effort from all the staff from MRC Lab, White Matrix, and the University of Alberta, and all these viewers online, especially for organizing the brilliant event. So as a U of A alumni, it's our honor to co-organize this seminar with my home university and backfeed the students there. White Matrix will continue contributing this kind of event in the future. And I am glad to conclude the success of the BMDS seminar and wish all the participants had a great experience in the last 3 days. Thank you very much.
Yeah, thank you, everyone. Yeah,
Thank you.
so it is the pleasure of our multimedia research group to be able to co-host this seminar with White Matrix and have all these brilliant mind speakers, panelists, right, to participate. So our students, and I'm sure the audience benefit a lot. And in fact, our multimedia research group, before the COVID, we organized 2 conferences called Smart Multimedia. So the first one was in Toulon, France. The second one was in San Diego, US. And then obviously last year we could not host because of COVID. But we hope in the near future, we can host the third one. And we are thinking of France. And we will certainly invite everyone. And if you have the time to spare, France is a nice place. Maybe we will go to Paris if the situation allows, right? So now, although we close the seminar here, we have the multimedia student project competition next. And if you have the time, you're welcome to stay and then watch the student projects. Thank you. Okay, so I won't take a break. Our multimedia students, are you ready? You can unmute your mic. And I want the first group. So the first group is Canadian wildfires data visualization for comprehensive analysis.
Hi, Professor Cheng is our team. So, but I cannot share my screen.
Okay, I will make you a co-host. Yeah, you can share screen now.
Let me share my screen. Okay, please let me know if you guys can see my screen.
I can see. So you have 10 minutes.
Okay. Hello, everyone. My name is Zijian, and today I'm going to present the final project proposed by me and my teammates Chu Yang and Zihao. Our project is the Canadian wildfires data visualization for comprehensive analysis. So if you have been in Edmonton in summer of 2016, you should still remember the forest fires that year. And in 2016, a forest fire broke out in Fort McMurray, which destroyed more than 2,400 houses and forced many oil sands plants to be closed. and more than 1,000 firefighters went into the fight, and in total, it causes more than $9 billion economic losses, which made it become the worst natural disaster in Canadian history. The wildfire is a very common natural activity. However, the cause of the wildfire is complex. It could be the dry conditions caused by the low precipitation, the lightning, the wind, and even the human activities. Since there are multiple causes of the wildfires, a comprehensive data visualization model will be more helpful for studies and researches. However, the existing solution provided by Natural Resources Canada does not include any comprehensive data other than the fire data. Therefore, we propose to build a comprehensive Canada wildfires data visualization that combines wildfire, wind, and precipitation dashboards for comprehensive analysis. So the visualized data in our project is collected from these 3 sites, which are the Canadian National Fire Database, the Global Forecast System, and the Adjusted and Homogenized Canadian Climate Data. In our project, we use Spring Boot and eCharts to build our data visualization dashboard, which include a Canadian wildfire historical data visualization, the 72 hours Canadian wind data visualization, and also Canadian precipitation historical data visualization. We use MySQL to host our wildfire database. So next, my partner Zihao will talk more details regarding the visualization dashboard. Thanks, I'll pass to you, Zihao.
Okay, thank you, Zijian. So next, I will briefly introduce the basic features of our system. In our visualization project, Canadian wildfire data are rendered as a scatter map and a heat map. In the scatter map, each wildfire incident is represented by a spot, and the size of the spot represents the fire size. The bar charts on the upper right of the map display some data analysis based on wildfire size. So in this case, only 5% of the wildfire incidents in 2019 are large fire, but this 5% of the large fire accounts for 99% of the total fire size. Okay, for scatter map, you can switch to the timeline mode for a better experience. In the timeline mode, wildfire records throughout a certain year can be automatically or manually displayed. Using the timeline, you can easily perceive the trend of the wildfire in this year, and you can easily switch the data between the months of the year. In the heat map, the color of the heated region is calculated by the frequency of wildfire. Regions with low frequency are rendered in blue, whereas regions with high frequency are rendered in red or yellow. For wildfire, wind is a significant weather element that affects wildfire. So in this project, we also implemented a wind map. For this wind speed and direction display map, we use OpenGL to draw dynamic line segments. So the line segments are drawn along the direction of the wind, and the color of the line displays the magnitude of the wind. Since the wind data is too rough when the unit is months and the wind direction information is lost, it is not helpful for our fire analysis. So here we actually use the wind data that is accurate to the hour. And as we all know that precipitation is another important weather element that affect wildfire. So the area with high total precipitation results in a lower risk for wildfire. So to better help researchers to understand and analyze wildfires in Canada, we also created this dashboard to visualize the monthly total precipitation data. So in this dashboard, we use the effect scatter chart to represent the precipitation information by each month across Canada. Each point in this map represents a climate station, And the color and the size of the circle represents the total precipitation for that month. So larger circle with blue color means more precipitation around that region, whereas the smaller circle with red color indicates the low precipitation amount around that region. And next, my teammate Chu Yang has prepared a video to show some dynamic features of our system.
Okay, thank you for the house distribution. Could you please the video?
Okay, no problem.
In this description, I want to show some details that are not convenient to show in PowerPoint slides. In the file virtualization data page, the first thing I want to show is when you put your mouse on a file position, you can view the detailed information like longitude, latitude, which presents the position, and how many areas the fire is burned, and when this fire happened. On the right up corners, you will see two pie charts. The left one is based on amount. They both shows the ratio of between the large fire and the smaller fire. The left one is based on amount, and the right one is based on areas. When you put your mouse on the pie chart, you will see similar things like the fire position. It will show you the detail, amount, and the percentage. The file visualization page, you can select when the data you want to look at. You can select the whole year, like what we do right now, or you can select the month, like February in this case. You can see there are only two files here. If you do not want to see smaller file like this, you can click the ignore small fire, and the website will only show the large fires. In this case, that don't have the large fire, so it has no fire effect to show. The timeline page is just like the one before, but adding a new timeline bar. So the timeline bar allows you to play through the data. It will go through month to month. So you will have a better view on how the fire changed. And also you can manually select the months to go if you like. The hint might provide users a straightforward feeling of which areas more often have wildfires. Unfortunately, our program is kind of that things. The wind page, we use OpenGL to automatically show the wind. At the beginning, we want to use the color to show the surface temperature. Unfortunately, we didn't find data can cover the whole Canada like the wind one. Right now, the color represents the speed of the wind, so we can view the wind speed at both color and how fast it's moved. Also, the time of wind is different from fire. It's based on hour. For the precipitation page, which is similar to the fire virtualization page, when you put your mouse on the point, you can see detailed information. Furthermore, you can use the color bar here to fill the point if you want. Okay, could you take to next slide? Yes, description. Okay, for the future work, the first thing we want to do is combination the three things together. Currently, they are in separate page because of different data setting and the limited of our library used. The second thing we want to do is add more information like the temperature I mentioned before. The third one is would be deployed to a server and change our website to the server-side render to save the amount of data in transaction. Finally, we want to try to build a script to update the data every day. Currently, you need to update the data manually because the data is come from different websites and different format. Okay, thank you. Finally, does anyone have any questions?
Yeah, we can have 2 to 3 questions from the audience.
I have a question.
Yeah.
So why the distribution of water is different from the wind?
You mean like the data show is different?
Yeah, because the water is like the many independent points, but the wind is the lines.
Yeah, that is the main issues we are facing on the data. So all the data provided by Canada government is based on the weather station, but we want to use data from the satellite, but the Canada government doesn't provide data like that. So we can only use the station data.
Okay, I see. Thank you.
So any other questions from the audience? If no, then we move to team 2, flight data analysis and visualization.
Hi, hello everyone. I hope that you had a great time with the design a flight tracker. As you can see here, you have a starting point, and here you can see all the packages and the APIs that we use. For the sake of this project, we use all the real-time databases for the for the flight tracking from the aviation age, and different open source libraries which facilitate the implementation of this project for us. We use the open weather to receive the forecast of the weather in a real-time way. And we implemented this project using these basically open source or open source packages. So let's get it started. So as you can see, we retrieve all the information related to the international airports in a Canadian-wide. And after that, the user is able to click one of the airports, for instance, let's say Parson International, and we retrieve all the weather data in a real-time manner related to that airport. And you can see the local time here is 23, and the temperature and the sunrise and all the information which is required as a passenger or a person who's gonna have a flight on the first page. So you can easily choose another airport or Vancouver, and the data will be visualized in a real-time manner for you. The next page will be the schedule. In a schedule case, based on any keyword which is required or you have on your ticket or as a passenger, or you want to just go and pick up someone from the airport, based on any keywords that you want, you can just do a search, and then the flight's status, the name of the flight, the origin of the flight, it depends on if it is arrival or departure, flight number, ETA code, and the schedule or the departure time will be show for the user. In the case of the departure, for instance, if we say, for instance, let's say Edmonton, then you can see all the flights related to the Edmonton airport here, which they are active or scheduled, or for the different cases can be visualized for the user. I just want to pass to Javanna, which is my teammate. I forgot to introduce her in the first of the presentation, and Javanna can take over of the next slides.
Thank you, and just could you please share your screen, because I don't have access to just have the time.
Okay, sure.
Okay, thank you. For the third page, in this page, as you can see, we have a date picker. We can choose a date, and at the bottom, we can set the arrival or departure flight. And we click on the fetch button. After that, it will get the data from the database and show the information as a circle on the map. As you can see, it will take some time, but at last, it will show some circles with different radius that shows the departure or arrival flights for a 7-day for that airport, and it will be shown on the map on the location of the airport. And also it will use this information to draw some donut charts about every airport and give here you can see the result, and here you can see the information about every airport, about their arrival or departure flights based on the airlines that they came or for arrival or departure have flights to that airport. And at the 4th page, we will have 3 tabs: global, arrival, and departure. On the global tab, we will fetch the data and get information about different current flights, considering the airlines, about all the global airlines, and draw it on a donut chart. And after that, in the arrival tab, by fetching data, we will get information about arrival flights to each airport of Canada on the map, and just by clicking on every airport, all the flights that are departing, or here we got the arrival flights. As you can see, you will see all the flights that are arrival to this airport, and you can change the airport and see which airport, which flights are going to arrive to that airport. And the departure tab have the same approach, but for the departure flights, you can see the you can find the flights that are departing from each airport and visualize that on the map, as you can see. And that's the end of this part.
Okay, so is the presentation done?
Yes, we are ready to take questions if there is any.
Yeah, time for 2 questions from the audience.
Hello, can you hear me?
Yes, sure.
Okay, so I have a question. At the very beginning page, there's only about 10 airports. Is that all airports in Canada?
Yeah, and the question is if we have more airports available in Canada or not. Yes, there are a bunch of local airports. But in this project, we just focus on the international airports to prototyping this project. However, based on the database that we have, we are able to retrieve all the flights from different airports. There are around 650 airports in Canada, including the locals and internationals. But mostly from the locals, you don't have much flights. So for the sake of visualization, we use this just international airports. However, the application can be scale up to the international and the local airports as well. And we can include whatever information we have on the database to these kind of maps.
Sure, that's great. Thank you.
You're welcome. Thank you.
Hello.
Hello.
So can I ask a question about the project? So I see the title of your project is Flight Data Analysis, but actually I didn't see much data analysis part in your project. It's more like a ticket website.
Okay.
So my question is, so have you done any part related to data analysis in your project?
Yes, great. The question is if we had any data analysis on our project or not. I should say yes, we had a data analysis, actually mostly post-processing, but we had included for those calculating the number of percentage of the flights which they are globally on the sky, or they are arrival or departure. All those things, they are not available directly from the APIs. So we need to retrieve the data from the database and then post-processing and do the analysis on them to calculate the portion or number of the flights or the arrival or departure times sometimes, because the database just provide the local time by changing the hours in order to make it presentable for the person who is, for instance, having access on Edmonton to this website and want to see the local time on the Toronto Parson Air International. So we did this kind of analysis or calculations basically for data visualization.
Okay, thank you for the question and answer. Let's move to team 3, interactive 2D and 3D visualization for COVID-19 with data analysis.
Yeah, that's our team.
Okay, I set you co-host.
Okay, thank you.
Yeah, you're good.
So can you see my screen?
Yes.
Okay.
Okay. Yes, so yeah, hi everyone, good evening and good morning. So my name is Irene and my partner is Mishan. Today we are going to talk about our final project for the course MM804, which is an interactive 2D and 3D visualization for COVID-19 with data analysis. Okay, so yeah, as we all know about COVID-19, we start just with some brief background info. So COVID-19 is an infectious disease caused by a newly identified coronavirus. And up to today's date, the total cases, confirmed cases in the world has achieved 136 million. And in Canada, the total confirmed case has achieved 1.07 million. So meanwhile, multiple variants of the virus that cause the COVID-19 are circulating globally. And currently in Canada, 4 vaccines have been authorized and up to today. So in this project, we have designed and created a website featured in both 2D and 3D for tracking and visualizing the current global state and global state, and as well as the state of Canada under the pandemic. There are 3 main problems that we are trying to solve in this project. First, question is how to effectively display all the meaningful data on the dashboard. And second, which metrics that should be tracked to gain useful insights for data analytics. And last but not least, what is the current progress of COVID-19 vaccine in Canada. So first, in order to effectively visualize the data, we have used graphs such as maps, bar charts, and also the interactive infographics. And second, for tracking of the current state and promoting future analysis, we have used metrics such as confirmed cases, infection rate, and vaccination administration per country, etc. And thus, in order to better understand the progress of vaccine coverage in Canada, we have also used a bar chart to compare the population of people who have taken either 1 dose or 2 doses of vaccines for any of the 2 selected vaccines. And here is a brief slide that talks about our methodology. So for front-end visualization and implementation, we have used libraries of Apache eCharts, React, D3.js, and global.jl web components using JavaScript, and various chart types, and as well as the 3 models are included in these resources with the full utilization of the modern browsers and as well as the performance guarantee. So our data sets are retrieved from the website of our World in Data and as well as the Worldometer and the Government of Canada. Table includes reported case by country and vaccination coverage rate as well. APIs are also available for Worldometer to access the latest daily updated data from it. And here is a brief demo about our website, which is mainly compressed by 5 parts. So each of the parts is
Sorry.
is responsible for the visualization and analysis of different metrics. The first part shown here is a 3D globe that is used to visualize the summary of the reported cases globally. So when you hover on a country, the corresponding info will be showing. The bottom slider also allows the users to interactively play the model and see the trend of the COVID-19 cases starting from January in 2020. And the rest of the feature of our web applications will be showing by Mission. I will pass to you, Mission.
Okay, thanks. In the next part of our presentation, I will introduce the 2D visualization part of our website. For the 2D part, we developed the geographic map and some interactive bar charts to visualize the situation of pandemic and the vaccination in the world. And both of the maps and bar chart were implemented based on the eChart, which is an open source visualization library. And there is a video to demonstrate this part. In the confirmed page, there is a 2D world map to visualize the confirmed cases in the world. When we hover our mouse on one country, it will show the information about this region. And we also have a color handle to make the visualization map more intuitive. As we can see, the region with the color of red has the highest number of confirmed cases, while the light colors means the corresponding regions have relatively less confirmed cases. And additionally, we can select a date from the time picker and click search to load information about the selected date. And we also visualize a map on the confirmed rate, because the total number of confirmed cases actually cannot explain everything. And as we can see in the bar chart, even though the total number of confirmed cases of some European countries are very low, but actually their infection rates are very high, even higher than America. And apart from confirmed cases, we also visualize the 2D map for death cases and recovered cases and vaccination. And here is a map for the vaccinated rate. And as we can see in the bar chart, although the total vaccinations in some countries are very high, but actually their vaccinated rate are still very low. So in order to achieve universal immunization, we still have a long way to go. And additionally, we also have a page to display the details of vaccination in Canada. For example, we can choose 2 provinces and click search to show the information about the population who has received 2 doses and 1 dose. And at last, there is a page to show all the information list. This is our individual contribution. Xingran was responsible for the 3D globe visualization, and I mainly work on the 2D world map part. So that's all about our presentation, and thank you for your listening.
So we have time for 2 questions from the audience.
Hi, Ming-Shan and Xingran. I have a question. Yeah, I noticed when you do a demo, you are using the local host. And I think this is a very good website. Are you planning to publish this website to some servers later?
No.
No? Okay.
Why? Why not?
Yeah, we will. Cause like for now, like the time is a little bit limited, but if in the future, and we still want to have like more features including after we like do a more like fine tune like the front end stuff, we will also consider if we could publish this website in order to also help people that to use the features that we provided on this web application.
Right. Actually, in the last class, Francie just left, and the group already posted a covered dashboard. If you go to our multimedia research group website, you can see the link there. So you can compare the features and see probably, it seems to me you have more features because 3D and 2D, and there's it's only 2D. So you can take a look.
Yeah, sure.
Okay.
Okay, so if no question, we move to team 4, realistic face animation from video.
Yeah, that's our team.
Okay, I make you as the co-host. Good to go.
Okay, thank you. Can you guys see the screen?
Yes.
Okay. Mingshan will go first.
Okay. Hello, everyone. This is Mingshan, and my partner is Zihao. Our project topic is 3D face reconstruction and animation generation from videos. In this presentation, I will first talk about the background of our topic and introduce the PRNet, which is the state of the art in this field. And then my partner will introduce our proposed improvement based on PRNet and show the demo. With the rise of live video, face animation stickers have become a must-have video technique. And as the core technology behind these face special effects, 3D face reconstruction has become a hot topic in academic research. So how to reconstruct a 3D face from a 2D image? There are several commonly used existing methods. The first one is to apply deep learning network to estimate the parameters of a predefined face model, such as the 3D and then reconstruct the 3D face by rendering these parameters on a facial template. The drawback of this method is that the performance of the deep learning model is restricted due to the limitation of predefined face model. To address this drawback, some end-to-end methods like volume regression network were proposed. This network accepts an RGB image as input and directly output a 3D volume. However, although this method has been proved to outperform the predefined model-based methods, the output volume has very high dimensions, so the computation cost is actually very high. So in this project, we adopted the last method, the PRNet, which is the state-of-the-art in 3D face reconstruction. PRNet is composed of an encoder network and a decoder network. Different from the volume regression network, the output of PRNet is a 2D image, which is also named as the UV position map. So what is UV position map? As you can see in this image, the UV position map is a 2D RGB image that can store the 3D information. In other words, the 3D coordinate of the face are respectively stored in the RGB channel of the UV position map. And since the shape of the UV map is only 256 times 256 times 3, which is much smaller than the 3D volume. So using the 2D UV map as the target output, the training efficiency of the PRNet is much higher than that of the
volume regression network. And another highlight of the PRNet is the weight mask used in loss function. And since in our 3D phase reconstruction problem, the features in the central region of the phase are more important than other regions. So a weight mask, as is shown in this image, is used to form a new loss function based on the mean square error. So therefore, with the UV precision map used as the output and the weight mask used in obtaining the loss function, the PRNet can not only achieve high accuracy, but can also run faster than real time. And in the next part, my partner Zihao will introduce our proposed method based on PRNet.
Yeah, hi everyone. So in the following presentation, I will introduce our proposed methods, our experiments, and show you a quick demo. So our first idea is to use both the original image as well as a UV position map as the input of the PRNet. Since all the 3D facial information are contained in this UV map, fitting it into our model may be beneficial for the model training. So for this method, during the training, we use the original image as well as the UV position map that is generated in the previous epoch and concatenate them to be the input of the PRNet. And for the testing, we adopt a two-step strategy. So in the first step, we input the model with all zeros UV map and the original image. Then we can get a sample output UV position map. So in the second step, we use this output image again as the input, as well as the original image, and concatenate them to be the input of the PRNet, and we can get the final result. Our another idea is to use multiple frames as the input of the PRNet. As you may notice in this video, the generative animation has some jitters, and that's because all of the previous methods are reconstructing 3D face models from single image. So sometimes even just a slight facial movement will result in a large jitter in the animation. So therefore, we change the input layer of the PRNet and let it accept a stack size of the video frames simultaneously and let our model to extract information to these frames at the same time. We think this method may be helpful to reduce the jitter. And to train a PRNet model, we need to teach the model to learn the mapping relation between the original 2D face image to the UV position map. So we need the ground truth UV maps. Therefore, we picked the 300 WLP dataset as our training and testing set because it provides both the original face images and the corresponding annotated 3D MM parameters. And these parameters can be used to reconstruct the 3D face model, so we can easily obtain the ground truth UV position map. And for the experiment, we use the normalized mean error to estimate the performance of our models. The normalized mean error can be described in this formula. The capital N denotes the number of landmarks, and delta X and delta Y are the deviations between the predicted and ground truth landmark. D is the normalization factor, and in our case, we use the size of the bounding box as the normalization factor. You may wonder why we need to do the normalization. So the idea is to, for deviation in a large bounding box, adding a normalization factor here will result in a higher error value. But for a large bounding box, the D here will be extremely large. So our error will be more tolerable to those deviations. And our experiment results are summarized in these two tables. So first, we estimate the normalized mean error on the 300 WLP testing set. But unfortunately, our models failed to outperform the original PRNet. And Mingshan and I had some discussion on the bad performance. So for the PRNet UV, which is the model that use UV position map as the input, during the training, after being trained for some epochs, the generated UV position map is actually very close to the ground truth. So our model can extract very useful information from it. But during the testing, the ground truth or the accurate UV position map is actually unavailable. So using inaccurate UV position map may bring in some noises for our models. And as for the PRNet multi, which is the model that uses multiple frames, the main issue for this model is that we can't find a suitable video-based 3D phase dataset. So I believe that further training this model on a suitable dataset can significantly improve its accuracy. And also, we estimated the average runtime in milliseconds per image. So for all of these three models, they can be used for real-time application. And eventually, I'd like to show you some results of our models. So the three windows here are the predicted landmark position, the estimated phase pose, and the 3D phase dance alignments respectively. For most of the cases, our models is working well, but sometimes it still have some offset. And that's because due to the hardware and time limitation, we only trained our model on a small dataset containing like 1,700 samples. So if we train this model on a larger dataset, I believe the model will be more generic. Yeah, and the table here displays our individual contributions, and that's everything about our presentation. Thank you for your patience. Is there any questions?
We have time for 2 questions.
Hi, I have a question. So for the weight mask, why you choose mean square error as the loss function? Did you try some other loss function?
Actually, we didn't try it because in all of the related literature, they are all using the mean square error. So this is the most commonly used error function, loss function in this field.
Oh, okay, I see.
Okay, thank you. So if no other questions, team 5, flow-based video mapping.
Hi, Professor Cheng. It's me again. Can you?
Yeah, you are already a co-host. You can present this.
Okay, yeah. Can you see my screen?
Yes.
Okay, so hello everyone. It's me again. My name is Zijian, and me and my partner Xinran are going to talk about our project, the flow-based video segmentation for human head and the shoulders. We would like to thank our mentor Xuan Yi for her guidance and the support. The video background replacement aims to extract the foreground from the input video and then combine with a new background. The methodologies of the background replacement can be divided into video matting or video segmentation. Video matting can perform visually detailed composites but requires very detailed manual annotations, which called the alpha mat. While the background segmentation focuses on the labeling the pixels between the foreground objects and the background. So the performance is much faster and more efficient. In this project, we focus on detecting the human head and shoulders from a video and remove the background to create elegant media for video conferencing and the virtual reality applications using the video segmentation method. The video segmentation with motion blur is challenging that even the state-of-the-art learning-based model cannot handle it properly. Here's an example video I recorded using the Zoom meeting. As you can see, I'm waving my hand. However, the Zoom's virtual background application cannot detect my moving hand accurately. So to overcome this problem, the problem of the motion blurs in the video segmentation and produce accurate background segmentation, we propose a flow-based video segmentation model called finite. And in our model, we first estimate the optical flow based on 2 frames. From this graph, as you can see, since the human body is not moving too much, so the optical flow for the body part is not obvious. However, for the moving hand and arm, the optical flow can clearly catch the moving object. And after we estimate the optical flow, we further extract the magnitude information as the motion feature for each frame using an indicator function with a threshold alpha. And in our experiments, we found the best threshold value is 0.4. And after the motion feature extraction, then we fuse the motion feature and the appearance feature from the original frame and feed it into an unite architecture to perform the video segmentation. Since our video segmentation is a binary classification problem, we use the binary cross entropy loss with the pixel-wise softmax as our loss function, where the Cn denotes the predicted probability of the nth pixel, and the On denotes the ground truth value of the nth pixel. Since there are not much conference video style public dataset for our project, we created our own video segmentation dataset. The source data includes 10 online conference style green screen videos, as shown in this slide. And then we extracted 3,600 frames from those 10 green screen videos and generated the ground truth mask for each character in the video. And then we applied the virtual background to the frames as our data set for training and testing. So next, my partner Xinran will talk more about our evaluation method and the short demo for our project. It's your turn, Xinran.
Yeah, thanks, Jen. So next, I'm going to talk about our evaluation method and as well as a quick demo for our project. So for evaluation method, during the validation and testing, we have used the dice coefficient, which is also known as the F1 score, in order to evaluate the performance of our proposed network. And dice coefficient calculates the sizes of the overlap region between the 2 segmentation masks and divided by the total size of 2 masks. And the result is the value ranges from 0 to 1. A higher dice coefficient indicates a better performance, which detects a greater similarity between the prediction and its ground truth. And in our experiments, 80% of the data set is used for training, and the rest of the 20% is used for validation. So here's a short demo for our project. Our experiment evaluated the proposed model on our testing dataset, which contains 2 video sequences consisting of a total 935 frames. In each video sequence of our testing dataset, the background images and the foreground human figures are unique and different from our training dataset. The background removal result is very promising, as you can see from the example showing here. And the overall performance on the segmentation is also very promising, with our average dice coefficient on the testing video sequence equal to 0.96. And one sample frame of our evaluation results are shown on this slide. So in conclusion, we proposed a novel flow-based encoder-decoder network to detect human head and shoulders from a video sequence, and as well as remove the background to create elegant media for video conferencing and as well as virtual reality applications. We have also created our own conference video style segmentation dataset, which is called the conference video segmentation dataset. So in the future, we would like to improve our model by implementing a fully convolutional encoder-decoder network, which is inspired by the DeepLab version 3. Also, we would like to improve our model with the softmax splitting method in order to warp and generate the mask between every 10 frames. And last but not least, the morphological closing on an image will also be applied in order to remove small dark spots and as well as connect small bright cracks. And here is a brief breakdown of our individual contribution for this project. And that's all for our today's presentation. Thank you all for listening. Do you have any questions?
Thank you. Time for 2 questions. No questions from the audience? Sachin?
I think because we have presented this project to most of the audience in the class, and we have already asked a whole bunch of questions. We have already answered them. And yeah, that's why we expand our future work, so that's something we can focus on in the future. But yeah, if you have more questions, welcome to ask.
Yeah, so that's why I asked Sachin. Sachin hasn't seen your presentation before. Sachin, are you there? Probably there's a connection problem because Sachin is in India. Okay, so if no question, thank you. Let's move to team 6, video classification based on automatic content detection.
Your professor is me and Irene.
Okay, so I make you co-host. Yes, good to go.
So hi everyone, I'm Jiayi and my teammate is Irene Wang, and we are going to present our project video classification based on automatic content detection. So I'll first introduce the background in the dataset and our first method, and Irene will continue the second method. So as we all know, video classification problem is very popular nowadays. However, one of the greatest challenges is the lack of large-scale label datasets open to the public. So we found this dataset proposed by Google. The YouTube AM dataset is a large-scale label video dataset that consists of millions of YouTube video information. Here's the features of the dataset. And our project is based on this dataset. We mainly use 2 methods to implement the multi-label video classification. So the first method was a modification of the original NetVLA. NetVLA was originally used to aggregate spatial representation and was found to be more effective than the common temporal methods such as LSTM in the task of temporal aggregation of visual and audio features. However, one of the main drawbacks of the NetVLA is that the encoded features are in high dimension. As you can see, if we have an input dimension and the K cluster number and H hidden units in the fully connected layer, we will end up the parameters number represented by this formula. So the next VLAD is a mixture of the NetVLA over group features. The input vector SI is firstly expanded via a single fully connected layer, then a reshape operation applied. This is the same as the splitting the vector S into some lower dimension feature vector. In this way, the dimension of the parameter is reduced. So you can see the approximate parameter compared to the previous one here is tremendously reduced. So this is the whole diagram of the model. The video and audio features are encoded and aggregated separately with a two-stream architecture. And after the learnable encoding, the aggregated representation is enhanced by the SE context gating module. This is aimed to modeling the dependency among labels. Finally, a logistic classifier with a sigmoid activation is adopted for the video level multi-label classification. So here's our experimental results that we apply this model into the YouTube AN dataset, and we reached the global average precision 0.8, which is better than the original baseline using the NetVLAD, which is 0.7. And next, Irene will continue to introduce our second method.
Sorry, I don't think I can share my screen. Oh. Okay, so I'll continue. The second method, in the second method, our model is modified according to a multi-label image classification network, which contains two parts. The first is the feature extraction model, and the second part is the stacked GCN, which works as a classifier. So a directed graph is built over these label presentation, where each node denotes a label. And the stacked GCN are learned over the label graph to map these label representations into a set of interdependent object classifiers. So, okay, so graph convolution network, also called GCN, was first introduced to perform a semi-supervised classification. And the essential idea is to update the node presentation by propagating information between nodes. So the goal of GCN is to learn a function on graph G, which takes feature description, which is HL here, and the corresponding correlation matrix, which is A, as input, and update the node features as the HL+1. So for every GCN layer, the function can be written as this. Here, A represents for the adjacency matrix, and W represents for the transformation matrix, which is to be learned. H is, the small h here is a non-linear operation, and HL here is feature description, which is word embedding for our case. And okay, so now let's talk about how can we get the adjacency matrix. So we model the label correlation dependencies in the form of conditional probability. So Mij denotes the occurring times for label L and label J, and Ni denotes the occurrence time of label I in the training set. But if we only use the conditional probability, there will be an overfitting problem, and some rare co-occurrence may be noise. So here we use a threshold to filter the noise edges, and then generate this is the binary adjacency matrix. And after that, we also do reweighting to avoid the oversmooth problem. So In the graph, so that's all about the adjacency metrics. Now we're going to talk about the feature descriptions in our model, which is word embedding here. So in the graph, we defined the nodes are the labels. So the feature of the node is actually the words in the label. So the word embedding, is required to generate label features. So word embedding actually encoded words into, into real valued vector, such that the words that are close in the vector space are expected to be similar in the meaning. So we use the result of the GLOV method that is trained on the Wikipedia dataset to do word embedding here. And each label is represented by a vector with the size of 300. And here is some of our training results. As you can see from the result, using fully connected layers as classifier. It can be seen that in the GCN model, it is not as effective as the fully connection layer in solving our problem. And it also takes longer time to train. Here are some assumptions about the possible reasons. I think one of the reasons is that the original model, which did multi-label image classification, uses the COCO dataset, which is a rather small dataset compared to our video classification dataset. And there are only 80 classes in the original model, but in our model there are more than 3,800 classes. So I think maybe the original method of calculating the adjacency matrix may not work when the number of classes increasing like this. And also another reason is that in the original model, the feature extraction model and the GCA model are trained together, so their parameters are updated together. But in our model, we don't have the raw input. We only have the extracted features as our input. So there are fewer parameters to update during the training. So I think that could also be one of the reasons that why this doesn't work on our model. And I think that's all about the presentation. Any questions?
Gabriel?
Hello, good presentation. Actually, I was wondering if it's possible to have this system like retraining, like maybe every day, because as you know, normally videos are uploaded to the web like in a high, like in a lot of like many quantity of video nowadays. So how you can like maintain this network, and how you can like have a general or a more generic model based on the like on every new video of each day.
Sorry, I don't think I understand the question. Are you saying that there are many new videos uploaded each day?
Yeah, exactly. You know that on YouTube, you normally have like well, people upload videos every day. So how you can maintain this network to be like general with these new videos for each day?
Well, yeah, actually the data set is provided by Google, and they selected some of the videos to build this data set. And yeah, I think what you said is also a problem. If we use the graph convolution network to do the classification, it highly depends on the distribution of the data set. If we have new data every day, this method may not work. Yeah.
Okay. Yeah, thank you. And team 7, social media-based cryptocurrency sentiment analysis, prediction, and visualization.
Hi, Professor. It's our team.
Okay, I will
can-
make you
Can
co-host.
all our team members have the permission to share the screen?
Yeah. Let's
Okay, thank you so
see.
much.
Fang, where's Fang? Mingji. Not on this screen. Oh, Mingji, I can see it. Make co-host. And now I'm looking for Fang. Yeah, you can go ahead.
Oh, okay. Okay, so everyone can see my screen and hear my voice clearly?
Yes.
Okay. Hello, everyone. This is Nimbo. Today, me and my teammate Fei and Mingzhi will introduce you guys about our project, social media-based cryptocurrency sentiment analysis and virtualization. We will show you guys some basic ideas about the project and then follow with the methods behind it and some of our results at the end. Firstly is the background of our project. With the price of the cryptocurrencies skyrocketed, some machine learning and deep neural networks architecture have been proposed for cryptocurrency analysis and prediction tasks. However, many factors such as the demand, such as government policy, hash rate, and more, could affect the price of the cryptocurrencies. For many reasons, most cryptocurrency prediction algorithms are not very accurate, which leading to the investors' loss. The traditional method normally using the past cryptocurrency price to predict the future price. The problem here is the past price may lead to an increase in the future price, but there is no direct relationship between the past price and the future price. Like the stock, future price only depends on how much people want to buy it. In another word, the cryptocurrency's price only depends on how society trusts it. So to solve this problem, our team come up with a new direction, which is not to predict the price, but the price increasing rate. Due to the cryptocurrency based on the society's trust, our team decided to work on finding a relationship between the cryptocurrency increasing rate and the social media-based information. The first thing to do is collecting the data for model training. We use Twint, which is a Python crafting library, and we write a script to collect the Twitter data. Here is an example of the raw data we collected from the internet. Here we can see for each tweet, we have lots of information, such as the user ID, username, and tweet itself, and lots of other things. But for this project, we only use the tweet, the sentences people publish on the Twitter. We scrubbed all 7 years of Twitter, which has the keyword Bitcoin or BTC. And we also collect the seven years of the Bitcoin price and their hash rate from the CoinDesk and the Quadro webpage. Then we need to pre-process the raw data to model learnable data. In this part, we use the NLTK library to convert the tweet into the formal sentences. NLTK model has a built-in English dictionary, which will replace the words from the tweet to its prototype. After we have a prototype word list, we count the frequency of each word in the past 7 years and manually select the 11 most frequent keywords, which we thought might influence the future Bitcoin price. Then for each tweet, we calculate if there is any of these 11 high-frequency vocabularies appear, and make a one-hot vector for it as our new training feature, like this one. After that, we do a sentiment intensity analysis for those tweets. we use the VADAR sentiment model to find out if a tweet has a positive or negative attitude. After inputting the sentences into the model will return one number to represent the sentence's sentiment intensity. One plus one, like a positive one, is the extremely positive sentiment, and the negative one is the extremely negative sentiment. 0 is the neutral. And we will going to use this sentiment analysis as another feature for our model training. Okay, next Fei and Mingzhi will keep going and introduce you guys more about our project.
Hi everyone, can you hear me?
Yes, we can.
Yes.
Okay. Now let's talk about the data structure we used in the training part. We select 4 features related to the change of BTC price. This feature can be combined into different combinations and input into the model to discover its relationship to the change of BTC price. We choose the price, hash rate, Twitter sentiment analysis, and the Twitter keywords. The time range of our data is from January 2014 to December 2020. We slice the training data like this. For example, we can choose the 7 days hash rate and the 7 days Twitter analysis results as the input and the 8 days price increasing rate as the label. For the BTC price and hash rate, their value range change greatly. The difference between the biggest value and the smallest value can be over 10,000. It's necessary to organize their value range into a reasonable range. In this project, we normalized the BTC price and the hash rate of each 7-day group data using the min-max scalar into 0 to 1. This means each 7-day group data is normalized independently. And we also shuffle all data before dividing train validation and the test data set. Due to this part, you can see in this range, the change of BTC price is too stable. The model can hardly learn something from it. Now, this is what our data structure looks like. We tried these 3 machine learning models to predict the price change. LSTM, GRU, and the bidirectional LSTM. These 3 models are all special recurrent neural networks. They are suitable for sequence data problems, such as stock data prediction. This table shows the accuracy of those 3 models. This sign correct represents the amount of result which correctly predict the sign of the increasing rate of price. And the arrow less than 0.05 means that the arrow between the predict increasing rate and the ground truth is less than 5%. Therefore, if a predicted result has the same sign and as the ground truth value, and their difference is less than 5%, we deem that the result is totally correct. If a predicted result only satisfies the sign correct or the error less than 0.05, it's also acceptable. It is obvious that GRU has, GRU has the best result, prediction result when using price as the input feature, it has 72% results, satisfied both sign correct and error less than 0.05. We also calculate the new predict BTC price with the new price increasing rate using this formula. This figure shows the prediction price result of GRU. The change of the prediction and the ground truth are almost exactly the same. The dark green line is the test prediction, and the light green is the actual value. To evaluate the result, we use MSE and RMSE to measure the loss between the predicted value and the ground truth value. This table shows all of our evaluation results. Let's see the RMSE first. GRU with using the price as input feature has the lowest RMSE for predict the price increasing rate. And by LSTM using the hash rate as the input feature has the lowest RMSE for predict price. And also MSE have the same result. This is the comparison part. The first table is the result of other related work. This paper is using the same feature to predict the BTC price like us, but their predicted result is a BTC price. Ours is increasing rate. Their true RMSE value should be like this. Because their RMSE is using the relative RMSE. It is obviously that sorry. Both our MSE and RMSE of the predicted price is smaller than their result. Next, Minzhi will introduce our virtualization web app.
Thank you, Faye and Nimbo, and I hope everyone can see my screen. So from this part, I'm going to present.
Not yet. We can't see your screen.
No? How about now?
Yeah, we can see.
Good. So here I'm going to present the data virtualization part. In this part, there's three major components. One is the MongoDB, one is the Node.js, and the last one is the React. Start with the MongoDB. It's a cloud-based database. It's a distributed database that allows all the team members work on it at the same time. As it's an online database, it can be accessed anywhere and it's high secure. And we have designed the data structure here with all the tables that we need. The current size of the database only 4 megabytes, and it will continually growing when we continually analyzing our data. And the last one is the Node.js server. The Node.js service allows us to grab the data from the MongoDB and other field and area. So it follow the REST rules and it allow us to do the async request handling, and it also support the strong types data models here. And the last one is the React. We use many libraries in this React, such as the TypeScript, SAS, and Designs and Recharts. So rather than just talking all the components here, I'm going to show you a quick demo here, how it works. So here is our website, and in this website, we will be able to see the price, the Bitcoin price continually going in the last year, and it's climbing up is very fast. And as Faye and Nimbus mentioned before, we have inputted 4 different features to analyze the data. So one of them, we have a mixed combination here with all the features that inputs price, hash rate, and tweet. And we can select any models that we want to see to do the comparison between the real price and the data models. We also can select the day range that we want to see. Let's say we want to see, I just pick a random days here. Just pick a random days. So we can see that the data analyzed and the real price here. And we can also compare the hash rate and the real and the price that we predict here. And lastly, we also can, because we're getting all the data from the social media, so we have a test call to see what is the keywords is show up the most times in the last couple years. Let's say the Bitcoins have been shown up 24,000 times. And lastly, I also want to show you how our systems work. Our systems start from the Twitter's data, our twins to collect the data, our models analyze the data and put back into the MongoDB. Our MongoDB storing all the data. And lastly, the Node.js collect the data and put it into the React, and the React shows all the data, generate a graph to show all the data, and the users visit our websites. So for the future work, we can continually improve our models to improve the accuracy, and we can also try different social media, let's say Facebook's. We can try different in cryptocurrency, let's say the ETC, and also we can change our model structure, balance our database, and our website also can be improved. We can put it on host, we can run it real time, we can put more information there to make it make sense to the users. So for the conclusion, we can conclude that the past price is independent of the future price, and using the future price as a target, the results will be unsatisfied. And also, our web app can be convenient for all the users use to analyze the relationship. And yeah, there's many works we can do. And here is our contributions for our team members. And any questions?
Any question from the audience?
Yes, I have a question. So for your model, is the estimation more accurate for the most recent result or for long-term results?
Hi. I think for both of the short term and long term is accurate enough. For me, it's like almost like 70% for the entire time range. But I think for the earlier time it would be more accurate. But for the recently, like for last year and this year is not that accurate because you know, the COVID-19 and some like government policies change the affected the price of the Bitcoin a lot. So yes, it is.
Okay, I see. Thank you.
I know Tim will ask you a tough question. Tim.
Yeah. Okay. So yeah, because just to give some context, this is basically a topic also provided by White Matrix. So I also have a question regarding this the prediction model. So since you have done multiple models like USD and hash rate and maybe like the social media trends, right? So have you, because in the last question, so I think you just answered that due to there's some like noise or like the policies and all these kind of external like factors introduced, the model is not that accurate. So have you considered some like multi-model prediction, like maybe incorporate Twitter, Facebook, and also like newses from like important sources, plus the hash rate and also USD to have a kind of more like a more comprehensive model to maybe like a multi-model like kind of prediction model to do this kind of complicated task. Yeah.
Yes, you are right. Like we are thinking about that. Like because we right now we only have the Twitter information. Like I think add more like a social media information and other like different factors will like improve our model for sure. So we are gonna keep going to like do the research and find out if we can have like a better model using like other information from the news like Facebook like that. Like hope we can open the like a gate like to earn lots of money. Okay.
Oh yeah. Okay, so I think this is also maybe the next step. We are thinking of like maybe white matrix can also kind of help, or like we can incorporate, we can just cooperate to do this kind of things. Yeah.
Yeah. Thank you.
Okay. Thank you. So we move to the last presentation. If no more question. Team 8, Internet of Drones approach for real-time image streaming for surveillance and inspection.
Yes, hello everyone again. We did a project for our communication course for the Internet of Drones and basically the transferring of the image. Now, I and Jawana, we work together through this project. Practically, the main problem is that if you want to have a beyond sight of vision flight using the drone for doing any inspection in a construction area or for oil and gas or any kind of detection, you will face with the problem of transferring your data from your drone to somewhere in order to do the image detection or image analysis in general. Practically, we have 3 main approaches. One is edge computing. So you do all the computation on your edge on the embedded system, which either it is Raspberry Pi or it can be a Nano, Jetson Nano, or any kind of NVIDIA embedded boards. Or you will consider a trade-off between the edge computing or cloud computing, or maybe at the middle you are doing some fog computing as well. But the main issue is that this problem is twofold. If you do all your computation on the edge, you don't have much energy resources to do that intensive like deep learning implementation or in deep learning detections. On the other side, if you want to transfer all your image from the drone side to the cloud side, the bandwidth that which is available for the drone currently using the LTE networks are not that much. And in a case of you want to have like very high resolution image and do the image processing on any kind of image processing on those images, you're not able to practically transfer them on the real time to the cloud, and you will definitely face with a latency. So we wanted to come up with a balance of both methods, either edge computing or cloud computing. Edge computing is good because you can be more real time. Cloud computing is good because you're going to have more resources available on the cloud, and you can do basically whatever you want in the case of image processing or any kind of processing practically if you want to do. Another thing is there are several parameters. One of the important parameters is energy for the drone. You cannot have long flights if you do everything on the edge, so you prefer to send everything on the cloud. As I mentioned, the latency is another parameter. The scaling is an important thing because if you have a swarm of the drones and you want to send all those images through one specific LTE pipeline, you will be locked. You cannot able to do that. And another parameter that I mentioned is the resources. So we come up with a like balance of these methods, not totally on edge, not totally on cloud. which we will be, I will just introduce it in the next slide. So as I mentioned, the current approach, as you can see here for real-time streaming, based on the state-of-art available on the literature, is that using the RTP protocol, you transfer the either some part of the image or the whole image to the cloud. So as I mentioned before, and we are not able to send everything to the cloud on a high resolution. And if you want to do some pre-processing on the edge side, we are using some maybe deep learning or neural network algorithm or some classification method to detect those objects of interest and then send them to the cloud side. Which in this case, if you want to use the classification methods, then you are using more energy on the clouds on the edge side. So what we propose here as our methodology is using the autoencoder models. The autoencoder models, they have been used for several approaches. But what is the contribution of our research practically is that we use the socket programming. We train the model, two models that Javaneh will talk about these models later on more. We train the whole model and then we separate the weights. And we decided to send that decoded part, which is the decoded message practically, with a very low volume of the data, like less than like in kilobytes, to the other side, to the cloud. And then because we had a trained model, the autoencoder model, we regenerate the image and we are easily can do whatever we want to do on the case of image recognition or detection, or even video processing on the cloud side. So practically the main objective of the project was to design a prototype for the near real-time image slash video transmission for IoT infrastructure, while we are minimizing the processing on embedded system, and we use this whole pipeline for our aim. Meanwhile, there are some NVIDIA, for instance, provide the deep stream thing, but those projects are not open source, and you definitely should use the embedded their GPU embedded boards, either Nano or TX2 or Xavier Jetson from NVIDIA, in order to be able to run the deep stream things to transfer your high resolution data. So practically this kind of networks that we are proposing here is open source and is available, and it's I think it's comparable with the commercial and industrial methods. So I just passed to Javaneh to present the result of the networks and what we had for the training parts and the network that we are implementing in this project.
Thank you for your presentation. Can you just confirm if you can see my screen?
Yes, just we need you to go to presenter mode if it is possible.
Okay, thank you. As Shahrul said, we trained two models. One is our first model, which we name it base case. And in this model, we try to use less layers, and it is more simple. And we get the accuracy and loss in when we were training the model. As you can see here, the accuracy is about 1.6 to e power -5, and the loss is near 0.01. Also, we get the loss and accuracy for when we were training the second model, which is a super resolutional image model. As you can see here, the accuracy is higher, and also the loss is lower, and it's near 0. And we train these models. For the first model, we train it for 60 epochs, and for the second one, we train it for 70 epochs. As you can see, we want to have a better result for, so we try to have the second model with better accuracy and less loss. After that, we try to implement or deploy the decoder side on the cloud. So we use the Cyber, and to access that we use OpenVPN, and to have the access to the terminal we use the PuTTY, and WinZip was for managing files, and at last we use Wireshark to get some information about the transformation of data that we are doing. The results that we get from when we deploy the decoder to the cloud, we just try to send different number of images to the cloud and get the transfer duration for that. And here you can see the transfer duration for two models. The blue line is for model 1. As you can see, it is between 0 to 8 seconds for the first model, but for the second model, as we have more layers, and when we increase the number of images, the time to transfer was higher, and it comes to about 900 seconds. And for the transfer rate, also we compare these two models. For the first model, as you can see, we have some fluctuations because we do not have we do not have good control on the bandwidth, and it depends on other factors that it is not in our control. And for the second one, as we increase the number of images, you can see the result for the second model is higher, and also you can here see some results that we get from the when we get the output results. We try to compare them with the original image, and we use some similarity measurements to see the similarity of the output image and compare it with the original one. And as you can see here, the second model is working better, and the output quality of the image is more accurate, and it's the quality is higher. And we just check these in different images with different resolutions. And here you can see the result. This is for the first model, the image similarity measures for the first model. As you can see, MSE is near 0, but PNSR as has the inverse relation with MSE, it's better to be higher. For this model, it starts for the lower resolutional image from near 70.8 to near for the last image, which is the largest one, it comes to 15.7. And for the second model, we also get these results. And as you can see, the PNSR here is higher. It's between 23 to 13 for all the images, as you can see. And if you compare it with the first model, it is higher. And also mean square error is lower. And so it's this result shows that the method 2 or model 2 works better, and the image results will have higher quality. And as you can see, when we use a more complex model, we will have images with higher quality, but it takes more time to transfer these images. And also for the bandwidth, as depends on extra parameters that are not in our control, it may have some fluctuations. And for the future work, we can also implement object detectors to these models to be more appropriate for detecting, for example, oil leakage or surveillance results. Thank you. That was our presentation. And if you have any questions, we will be glad to answer.
Any question? How about Vincent?
Yeah, Professor. And I have some question about before is about I think you this group information about auto encoding network and actually could I see more detail about you're introducing about the evaluation method and can it run it very smooth maybe and in running on the maybe your platform, right?
Sorry, I didn't understand the question perfectly. Okay. Can you just explain me more? I do appreciate it.
Okay, thank you. Actually, you mentioned something you are concerned about latency, energy, scaling, resourcing, and your implementation the network auto encoding, right? And
that's true.
And the result seems good, maybe very perfect. And did you consider actually? I know because you mentioned some platform maybe the GPU energy is not like our server, right? And maybe actually have some method maybe we can make our network run more faster actually on our maybe embedding system, right? And you also send the image to the cloud, and maybe actually can we maybe train a module maybe can run both of them can run very smooth, right?
Well, the question is if we can run the model more smoothly on the edge or practically using both sides. Let me define the problem again. The problem is that when you're flying with a drone, you are using 2 small batteries, and maximum of the flight that you can have using a drone without any processing, just having the your autopilot like Pixhawk or whatever you are using for the flight as a flight controller, with just 20 maximum like 5 or 6 volts, because it's a very small board that you mounted on the drone and you start to fly. Depend on the drone size that you have. If we consider the commercial drones, the maximum flight time that they have currently based on the best battery which is available and you can fly is maximum between 20 to 30 minutes. So if you want to have the process on the edge using any embedded system, here we consider the NVIDIA Jetson. If you mount it to your drone and you want to do all the processing on the drone side, then you should use that energy which you were using for the flying the drone for 30 minutes. Then you should use half of that energy for at least half of that your energy for running the process on the GPU on the embedded system that you have. For the industry, it's very important to have a longer flight time because in a case of the surveillance, for instance, you don't want to land or take off multiple times. You want to have a long survey, and maybe it's not just one direction. You want to have different corridors that you are flying and surveying. So having all these parameters set, doing everything on the edge for the current drone industry is very expensive. Expensive in the case of the energy usage. So we would like to use the both side and balance this computation. I personally prefer that do everything on the cloud, but some industry they are eager to do some edge computing for whatever they reason have. So if you have a trained image and then send the image to your edge and then do some processing there, then you want to send it to the cloud, consider that you are going to run YOLO 3 on your edge. In this case, you definitely use more energy rather than do everything on the cloud side. So we have to transfer this image from the edge to the cloud in a very cheap way in a case of energy usage. So the proper approach for that is, and in order to run it smoothly as well, is using the autoencoders, either different classical ones or the deep learning ones. We choose the deep learning ones because I believe they can regenerate the different domain of the images in a very proper way, as long as you can implement the denoising on them, and you can compress the high resolution images as much as you want. So actually we compared this method as well with the traditional methods. We didn't present the results here, but if the NCC is high, and the result showed that they're really compatible. I mean, you can easily say that the lossless methods, lossy method like these autoencoder models can be compared with the performance of the lossless method. And I think it's a great idea to have these kind of systems for the drone industry. Did I explain properly, or did you receive your answer?
Yes, yeah. Thank you for your answer. Yeah, I think your basic project is very big, and we actually can do so many things. Actually, also we're also very currency, maybe access the server, maybe it also spend some pay money because we were using Amazon or Google Cloud. And I also ask question: do you consider about something about like STM, because autoencoder is okay, and something about deep learning method, maybe because we are edge, maybe as you mentioned, our GPU power is not very good. So some STM or network maybe can also use it, in my opinion, I think.
Yes, there are a bunch of things that we can do here, and we still just prototyping something for the future research. We need to compare this method with the classical methods as well, in a more, depth. However, we didn't measure the energy usage in a practical way on the drone. We need to mount this algorithm to the drone, on the drone, and then send the real-time data using the high resolution cameras to the cloud and see how's gonna be the performance of the models. And also we need to install have set up the detectors based on the application that we have. I mean by detectors, the object detectors or object recognition models like YOLO, ResNet, GoogleNet, whatever we are gonna use. And evaluate the performance in this case for both edge side and the cloud side, and then compare it with the current available commercial resources, which is applications or packages which is available currently for the industry.
So good discussion. In fact, Saurabh's coming up internship is on drone technology. I'm sure he will take all this into consideration. A lot of work for you to do, Saurabh.
Yes, exactly.
Yeah. So I will collect the evaluation from the judging panel, and we'll make a decision. And thank you for all the hard work on the projects, the multimedia students. And thank you very much for the audience. And with that, we will conclude day 4 of the seminar. And thank you for the interesting projects. Yes, that is to the multimedia students. I have to give a thumbs up and clap hand. Okay, so thank you everybody, and have a nice day, and good evening, good night. Yeah, I already posted in the chat, and we will send email to all the participants, and there will be a very short survey, and there's a checkbox. If you want to have the attendance certificate, you just tick the checkbox and we will email you. Okay. Thank you, everybody. Bye.
Bye. Thank you.
Bye.
Bye.